So look at this molecule here. We got sodium methoxide reacting with this alkyl bromide. I use this wedge line to show that this is a stereogenic carbon, and there's a stereocell. You really have to be careful when you see something like this, because SN2 reaction is not just substituting this bromine with this methoxide. I mean, first of all, is that the right answer? You really have to recognize what is a nucleophile. It's not the whole thing. Not the whole thing is a nucleophile. Sodium methoxide, and that's the name of this reagent, is not the whole thing replacing this bromine. That is not the right answer. What is a nucleophilic is that oxygen negatively charged. That's the one, the nucleophile. So that makes an attack to this carbon, kick the bromines out. That's an SN2 reaction. So if you write it in this way, I mean, that says that, yes, you recognize the right component of the nucleophile, and then you replace the bromine. But what you forgot to do it is this is a stereochemically defined carbon going for the SN2 reactions. We expect the inversion of the stereochemistry, which you didn't show here. So regular solid line means that we don't know what is the stereochemistry of the carbon. So that's why that, if you write it that way, I wouldn't say this is the wrong answer 100%, but it's not 100% correct answer either. So you get the partial credit. So this is not the way you show it. You sometimes recognize, oh, sure, and then maybe I should just make it same as a wedge there. This same wedge means that, yes, you get the substitution done, but you didn't get the stereochemical inversion. So that is not right either. So what is the right answer is this one. You got the methoxide approaching this one from the back side, so it attaches on the bottom side of the cyclohexane, and then you get the bromine kicks out. So it sits on the opposite side of the bromine, so that's why it's dashed form, not the wedge form. So I want you to make sure that whenever you have to show the SN2 reaction, the stereochemically defined molecule, you really want to be careful about when you draw the products. You've got to draw the stereochemical inversions, you've got to draw the right substitutions, right, in the right positions. So there are several things that you need to consider before you make the answer. Question? Okay.
Yeah. So when you've got like the bromine that's got the wedge coming out, in theory, on that carbon, there's a hydrogen that's going back.
Hydrogen is on the bottom.
It's on. Oh, it's on the bottom. Okay.
So that has to be pushed out. You see that all the things going to go the other side. So this hydrogen was at the bottom, right, with a dashed line. That's when this makes an attack, that's going to push it up. So hydrogen is now going to be wedged line there.
Okay.
Yes, because it's going to be all moved up. So that's pretty simple. So you thought that you know what to do, but a lot of people also make some other mistake. I'm going to show you what you don't want to do. It's kind of same reactions. Now you know that methoxide, that's the nucleophile, makes an attack to this carbon. That's something that we just talked about it. And then you remember that it's going to come with a stereochemical inversion. You're just going to flip the stereochemistry. So you just change that to the dashed line because you use a wedge there. And then you just know that, oh, there's another dash there. I just changed that to this one. So that seems to be, you did everything that I asked you to do, right? You just do substitution with a right nucleophile, reverse the stereochemistry or all the sub-chiral carbons, and that has to be the right answer. But unfortunately, if you do this way, I'm just going to cross it out. This is not correct. Why is that? Why this one changed the stereochemistry is because the nucleophile makes an attack from the opposite side of the carbon, and then bromines leave on the top side. So this stays in the bottom, bromine leaves to the top. So that's why these ones go to here with a dashed line. But nothing happened to this carbon, right? That carbon, nothing happened. So there's no reason for that carbon to change the stereochemistry. So only the carbon where the reaction happened, this is the one that changed the stereochemistry, not this one. So don't just automatically invert every stereochemistry chemical carbon, because that is not the right way it happens. So if you just memorize it, I'm just gonna switch the dash to wedge, the wedge to dash, and I'm gonna do all of them. That's gonna be all the answers come from the simple memorization of the how to solve the problem. Right? You just know why things happen, so you can avoid this type of mistake.